Assalamualaikum warahmatullahi wabarakatuh. A very good morning and greetings to all. On behalf of the organizing committee, I would like to extend a very warm welcome to all our distinguished guests, speakers, researchers, and participants from various polytechnics, universities, and industries. We are thrilled to host the International AGROFOOD and Biotechnology Festival at Special Education Needs, an event designed to celebrate innovation and foster collaboration. This festival is a testament to our collective commitment to advancing knowledge in agro-food and biotechnology, with a special focus on creating a more inclusive and accessible future for all. Thank you for being a part of this landmark event. Next, the floor is delighted to invite our guest speaker for today. Allow me to provide a brief introduction about our speaker. He is a professor at the Faculty of Engineering, State University of Malang, Indonesia, with an extensive experience in the field of electrical engineering and informatics. Today, he will be sharing his knowledge with all of us. The title of his talk is Agriculture IoT, from Lab Innovation to Sustainable Impact. Without further ado, I now invite and welcome Professor Aripriharta to begin the sharing session. The floor is yours, Professor.
Okay, thank you very much, Dr. Raja Nadia Binti, for a great host today. For confirmations, can you listen my voice? Okay. No one confirmed. I think it's listening well here. Yes. Let's share my screen first. Can you see my presentations? Okay. Okay, thank you very much. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah wa syukurillah la hawla wa la quwwata illa billah. Very good morning, everyone. Thank you very much for Polinilai and another university that hosted, also the sponsor. Thank you for the director and the lead of the committee of this iFAMB at SEN2025. My name is Aripriharta. I'm a professor in the Universitas Negeri Malang in Faculty of Engineering, Department of Electrical Engineering and Informatics. Today I will present with happiness the agriculture IoT, from lab innovations to sustainable impact. And my presentation would be about the global dilemma of food security, agricultural IoT, the heart of modern farming today, technological foundations of agriculture IoT, benefit, challenge, and barrier, closing the barrier left to field, use cases, and conclusions. Since the audience probably have a lecture, professor, industry, and students, so some of my presentations will be the use case from our laboratory and field. As we know, the global dilemma in 2050, we will feed 60 to 70% from today's food supply. It's because the populations rise up from 8.1 to 9.7 billion in 2050. It's a very huge number. So the challenge is clear: feed more people with fewer resources in the changing climate. Without innovations in agriculture, food security becomes the next global crisis. So let's we go. What is the need of advancement in technology, especially in agriculture, to relate with the food supply grow in 2050? We can remember the past innovations of agriculture's kind of tractor, something like a mechanized farm. Oh, sorry, my slide is not moving. Yeah, sorry. In my computer is a move. I don't know. Try again. Can see the slide here. I use slide so. It's okay now? In display. I will extend this slide first. Can you see?
Yes, sir.
Hello? Ya, sudah saya tekan nih slide show. Dia tidak move. Kita tes. Dia move. Dia ganti layar, oke? Tidak? Kenapa tak bisa ya? Begini saja lah ya. Oke lah. Oke. Oke, ini saya oke. Saya coba change dia next. Bisa? Saya try again slideshow, oke? Okay, thank you. Sorry for the problems. It's just a technical problem. So we continue for the today lives. Agriculture IoT now is become the key of technology advancement in agriculture. The outcome is a data-driven, proactive, and sustainable agriculture here. What is it? Agriculture IoT use sensor networks, automation, and intelligence to turn farm into data-driven systems, helping farmers grow more with less. I repeat it, grow more with less while advancing food security, sustainability, and resilience. Okay. Okay. So we continue to the architecture of agriculture IoT. As you can see in this picture, the agriculture IoT, in simple, make the farm barns talk to the farmer. So we use devices like this. We use a sensor, actuator, and processor, Wi-Fi connection, IoT gateway. Since it's put in the remote stations, they need another power that's come from renewable system like a PV, hydro, or wind energy. Then transferring to the cloud and sent to the farmer through web applications or native applications. I think no more problem about the display now. I will continue to the sense technologies. The sensors usually used for agricultural IoT is a soil sensor, including moisture, nutrients, pH, and temperature sensors. Also, we can show the plants grow, chlorophyll, stress detections, diseases, and anything else. Also, the animal, of course, and the water quality. As you see, the math here is very simple. The sensor signal plus the error in the stochastic manner. This is the example of one sensor uses soil moisture sensor that synthetic data from the our lab. Then the connectivity and networking. We can choose according our applications, of course, usually now still Wi-Fi or cellular technology. As you can see, if you need the coverage, you use the LoRa or NB-IoT. And if you need the data rate locally, you can use Wi-Fi and balance coverage with high throughput. You can use cellular connectivity. This is the gateway. The another use devices in IoT agriculture. Maybe this is the most common use in laboratory, and we can choose a different connectivity type for the router. And of course, the point beside the IoT is AI. Each AI for real-time decisions has the issue about the latency and the cloud storage also. For the long-term trend, we can check in, for example, for the weather stations and weather data, the soil data, water data, the animal plays in the livestock monitoring, and plant grow monitoring also can use this agricultural IoT. Data analytics and artificial intelligence can use for forecasting. This is the most issues today for researchers, including academic and industry. And the interesting thing is anomaly detections, animal stress, crop disease, and water quality is a big issue today also. And for the researchers, like the mathematics can put the multi-objective optimizations for knowing the trade-off, as we can check its variables using some ablation study and multi-objective algorithm. We can measure the sustainable impact of the agriculture's IoT. I will show you later. And decision support for the farm. Of course, the energy system, because the farm located remotely from the city, so we need the sustainable and continuous supply for our devices is can use the battery or solar PV, wind energy, and hydro for some cases. Of course, the low power is a give a big difference for a lifetime of our sensors, network, or IoT nodes, and batteries per capacitor storage for off-grid operations also needed, as in the smart aquaponic or another system. And the user interface, this is the most important for the farmer. We must bring our applications more user-friendly for the farmer, since we have a technological barrier for some farmer, since they normally use the traditional technology, and gradually change or rapidly change in technology may be some confusion of them. And how it works is simply like this picture. The farm barn will talk to the farmer. The field speak. The barn talk, and the pond report it to the farmer. So the farmer can easily enjoy their coffee to know everything about their farming status. And of course, using IoT, cloud, and AI to collect and manage and control, also predict from the signal. The farmer will listening their animal through the applications, and of course the guidance also put it, and knowing the results. Before continue to the lab project, I will show you the simple commercial agri IoT, like the UV dot and panic. Also the drip irrigation kit, you can find it online in their site, and is a very useful applications. And this is the simple open source for hobbies for the students, especially for polytechnic students. They can operate in their table like this simple one, only a single pod, using a single soil sensor, capturing the data, monitoring something here, operate and use AI for prediction for the next soil situations. What is the benefit of agriculture's IoT? Of course, as my first presentations, we need to increase the yield, enhance the growth, higher productivity at the multi-sessions. So we put it in places like this, in the greenhouse, to reduce the climate, and to make only one session in one place using the devices. Resource efficiency, of course, and real-time monitoring and decision support system. Environmental sustainability. This is the most important due to today's issue. Let's continue to challenge and barrier in the modern agriculture. High initial investment costs, technical skill shortage. Farmers might lack of necessary technical expertise of implementations here. So data privacy, when we connecting our devices through the internet, data privacy and security is most important for us to consider. The lab can be conditions, the greenhouse can make special conditions, but the real farmer places in the farmland, in the barns, they face the dust, rain, and heat. That's called the harsh environment for them, or the situations, and the power and connectivity, especially in Indonesia. The agriculture sites remote from the city, so the power and connectivity is important to consider. So how to closing the barrier? We use the lab resources. We can do simulations. We can make a trainer for simulate the outage, design the solar and low power solutions for our agriculture IoT. Connectivity also can be tested under the lab with many scenarios, and we can make the prototype that low cost for the farmer, and the usability. We can develop a simple way. Oh, sudah nomor 10. Maybe I'm not use the slideshow, just a manual like this. Can you see the slide? Okay. Sorry for the maybe the connection issue here. So use case for agriculture's IoT, the precision and smart irrigation, soil health monitoring, livestock tracking, drone-based crop monitoring, smart greenhouse, and smart aquaponic, novel sensors, algorithm, and platform also. The key feature are low power designs, wireless technology, and edge AI. So from lab prototype to field realities like this, in the lab, Agri-IoT work perfectly, but in the field, farmer face dust, floods, broken devices, and limited budget sometimes. This is the real gap we must bridge. So I'm gonna show you the sustainable impact metric. We can create the device, but the sustainable impact is more important. So I create the multi-objective optimizations model to measure what matter here in water saving, reduce fertilizer, pesticides use, etc. Increase yields and reduce the losses, the farmer income tax adoption rate. So we came to our first example. This is from Arduino CC, that smart irrigation system with edge control. Smart irrigation's water only when needed, and saving resources and boosting yields. This is the hardware here. You can check in the Arduino CC and see the interface and the smartphone or tablet. The multi-objective optimizations, we have a sustainable impact as a target. This is the model. Pure mathematics, but this can measure the trade-off of the system. Like this, we can see the Pareto forms here about the water saving, yields, and energy uses. The Pareto frontier help farmer choose depending the priority: drought, water saving, market demands, or yield max. And analysis here, we can check from this graph. I show you a 4 different graph: the farmer income, waterfall, resources output, yield, and versus input, like the last PowerPoint. last slide, and the adoption curve, the adoption of technology. In Indonesia, it's a very low adoption technology of about the 7 years, but the water use can save by the sessions too. The input also cut from 25 to 30%, yet income rise steadily. And we continue to the smart fish pond now. This is came from our lab, the prototype, a very small prototype. Before that, we use the sensor like pH, DO, and temperature, etc. Actuator to as a valve to make the water in and water out, to change the water. Also, the monitor the signal needed here for water quality and for the fish, etc. We use AI to predict the water quality and fish health. This smartphone application is very important, especially in Malang City, Indonesia, especially for the catfish, the favorite fish in Malang City. Even the Malang City cannot provide it for internal consumption of the Malang, and we export the catfish from other city. But after using the smart fish pond technology, the community of catfish in Malang City can increase their production, so reduce the import from another city. This is the deployment in the pond in the community, and this is the sample of the signal from the sensor, and this is the applications of the farmer. The dashboard can access from the tablet or a smart. Then we continue to the smart aquaponic system. Actually, I have animations here, but because I cannot use the slide, so this is run manually. The smart aquaponic is the circular system from the fish to the vegetable here. This is the simple example. It's commonly used in the community and houses in Indonesia. And the sensor also the same. We use the real-time monitoring, of course, for IoT, and the AI also predict or optimize the feeding, the growth of fish and vegetable, including the disease. Also, we use the renewable energy for off-grid for the bigger smart aquaponic application in the farmer or community. And this is the example of the field implementations and the dashboard here, not only for the water quality and the soil quality, also the solar power we monitor here, and the trend can show, including the predictions. The AI control loop for the smart aquaponic. So we have a sensor here, and for the AI or edge AI in the cloud and the devices, and the policy safeguard, then control the actuator like pump to aerator pump for the fish, and the valve to change the water. Also the automatic feeder and heater, since in the Malang City in the night is quite cold, it have a problem for the vegetable and the fish environment. And the more detailed applications of smart aquaponic, you can see like this. For example, we have a 2 tank here and 2 beds, and we know the schedule for tomorrow from our EI, and the system monitor here. We can use the pH level, ammonia, nitrate, and etc. All data sounds clearly. And continue to data flow model. Sorry, I saw the mathematics. I saw that our research in agriculture IoT is not only for the devices, but also the signal here is a very big issue for the researcher or industry, or of course the students, to learn that data flow model like this in the real-time actions, and for the long-term strategy, like weekly irrigation plan, year forecast, and etc. Then the model for age detection, for example, for dissolved oxygen, we can continue the pump or aerator pump to supply the oxygen. And I think this is the first model that I built for agriculture IoT that's usually researched by the devices only. But you can do research like this also. And the connectivity network can see as a multi-objective problem for the channel capacity like this. This is, I give you the model for maximizing the functions here, and some variable rated here. You don't have to write it. I will send the PowerPoint presentations later. This is the IoT devices gateway. Use the functions here for multi-objective for measure the payload versus energy, and energy versus the data, right? As I tell you before, energy consumption is also a big issue for the remote farming side. This is the area for the best situation, or the sweet spot. I call it a sweet spot here. We put including the noise. So this is a really interesting research in our laboratory. And today I have 42 PhD students in my department. Some of them interesting with IoT, and also focusing on the low power hardware or devices. This is for the cloud and edge computing. We saw in the graphic here clearly, including the prediction and the real monitoring. So this graph. And continue for the multi-objective for aquaponic. I think this is also the new model. You can do research also using this model, focusing on the duty of the aerator pump. Of course, in the lab scale is a very small, but in the field scale is a big trade-off for to consider. And this is the sum result. See here, for the aerator duty for dissolved oxygens, and the fish growth curve with a variability band, you can see among this kilogram. Or this is the biomass, and this is the days. This is not the fish weight, but this is the biomass resulted from the fish waste. This will fertilize the plant or vegetable as I show you before here. So the fish waste will come to the vegetable. And also we can see the PV or wind system for the energy consumptions, but I didn't show in this slide. Then we continue for the smart pump irrigation system. You see here the same, move from lab to the field. We put the blue colors is our students. They put our system in the also the before presentation, also the same. The blue color is our students. And this is the dashboard. You can see everything here. You can control everything from here. The farmer will train before using, and some of my students will stay there to train them. This is the age monitor for the heart. As you know, Indonesians is very like the chicken and duck for the food beside the fish. So this is the dashboard. You can see two students practicing in lab, then move the applications to the small community in the Islamic school boards that have the economical or have the small industry to sell the egg and the small chicken. I forget the English of the small chicken. And continue to the livestock monitoring using AI IoT. You can see here the anomaly detections, as I say before presentation, use the AI here to help analysis of the code here. Even you can see the current head rate of the code and the placement where they place now, the distance from the head center. They're spread it in the farming side. We can know the feeding alerts, location alerts, everything using the AI. Then I will move fast. The times go. This is the crop monitoring from our lab. The students continue to the field, the rice field here, and put our stuff here. Then use for the crop monitoring using the sensors, IoT gateway, etc. Like the usual of agriculture IoT is the same devices but different applications. Then the crop monitoring in the field, do this like this. Our students explain to the farmer and then practicing the devices. They use the dashboard monitoring like this. So we can check the farm land here, check everything here, even the disease. You can add a kind of disease here, and they will check if your plant have a disease like that. And it's for example, the crop inventory here, the corn, soybean, etc. You can see we can detect the issue here. This is use the AI because only IoT devices cannot do something like this. Also, the critical alert and health status is from artificial intelligence. And the dashboard for crop monitoring, as you can see here, the tail of the corn and tomato. This is just for example. And also we can check our weather stations under maintenance here where my students give this dashboard view. The most important is how to measure the sustainable metric like this. This is the crop monitoring, but I said this for next keynote. I hope have a lot of questions for this session, so I can share more to the students or to the participants here. But I show you this have a crop, including in area, air fertilizer, water emissions, also livestock. We can put the variable for feeding, emission also, and decisions for irrigations, spraying, ventilations, etc. Of course, the constraint can be extract more. You see, this is a lot of variable here. So to know the trade-off of each variable, we must model using multi-objective model, so we can know the contributions for each variable here and what is our objective in the agriculture development depend on our city, our country, or especially to the world. Oh, conclusions. I'm very happy to see this slide. Of course, the IoT and AI transform farming from reactive to proactive, both food security, environment, and sustainability, bridge the gap from the lab to the field applications, and reduce the input, as I said, of 30% to 35%, increase yields, both farmer income. And this is the big issue. We must increasing yields since the big increase in the population in 2050 is a world of problem. It's our duty as a researcher, industry, students, to care about it, to care about the human sustainability. Technology is not just a device, it's much concerned about the sustainability impact. So give you the animations. So this is the imaginations of me. Hope is of clothes will be achieved by us in the world. Maybe another country first do this kind of intelligent farming for the future perspective here. And this is Malang City. This year's the conference held in Polinilai. I hope the next years can be in our university, so the audience can see how beautiful Malang City. This is agriculture's area. You can see a mountain with a rice field and it's a vegetable. We have a 5 mountains surrounding the Malang City. You can see the waterfall. We have 1,000 waterfall here, and we have the ancient kingdom site. Also the church, mosque, of course, and I don't know what name of this, but it's very interesting. And this is the Kampung Warna-Warni. one of the icon of Malang City. So thank you very much. I spent maybe 10 minutes for the questions. I give back to the Dr. Raja Nadia. Thank you very much for the time. Assalamualaikum warahmatullahi wabarakatuh.
Thank you to Professor Aripriharta for the very beneficial knowledge shared just now. Next, the floor invites our moderator who will be leading this session. Please welcome Mr. Harvin Taredi to lead this session.